Thank you so much for being with us today, Ms. Kulkarni. It's really a pleasure to interview you. So, I think we'll get right into the questions. So, just to
Okay.
start us off, how did you get interested in this field? Was there a moment or an event or something that let you know that this data science was the field for you?
Okay, thank you. Thank you, Prashanthi and Ruthu, for interviewing me for this event. And I'd like to thank Ashoka University also for giving me this opportunity to share something about my background and my passion for the subject, starting from math. So I'll give you a little bit of a journey about my how I came from math to where I am today. That'll give you an idea as to how my journey progressed. Right. First of all, I'm very fond of maths. I was always very fond of maths and science, and I thought they were more interesting than any other subjects. And I loved maths because to me, it seemed like solving puzzles. I love to take a word problem and turn them into numbers and then do some calculations and get an answer. And it always seemed like, okay, there is a purpose to this. There are some problems in real life. You go to the store and your dad gives you 20 rupees, and then you buy 3 mangoes, 4 bananas, whatever. How much money do I have left? So even when I was growing up, my dad used to ask me questions like this, right? So to me, numbers were just not a black box. It was not just something that had no meaning. It had a meaning. And that is what got me interested in mathematics. So it was my dad who encouraged me. With regard to school, I found that until the 8th standard, I was in a girls' school. So it did not really make much of a difference whether I was the only girl or not, because we all studied maths and other subjects. So it was something that we all did, and I still enjoyed it, right? And sometimes I get asked this question, did anybody ever tell you that you're a girl, you shouldn't be doing maths? Why are you interested in maths? You're not really, what use is it to you? I must say I was actually quite lucky. Nobody ever said that to me. They saw that I liked it and that I was good at it. So my parents encouraged me, my teachers encouraged me. And in fact, when I moved to high school, I moved to a new town in Bhopal. We moved from the north in Patna to Bhopal, and I went to a co-educational school. And there I found that I was the only girl in maths. So that should have been scary, right? But again, my teacher, maths teacher, was very encouraging. And in fact, he used to always tease the boys. He used to say, he used to speak in Hindi. He used to say, "Arey ye ladki dekho kitna acha kar leti hai, aap logon ko kya problem hai," right? So that actually boosted my enthusiasm, and I felt like, okay, I've got to do this. So that's how I got interested in the subject of maths. And then, as I progressed, I went on to do a bachelor's and a master's in mathematics. And then I came to the US to do a PhD in mathematics. And then I switched to operations research, which is one of the fields that is included in any data science course as well. So when I started doing linear programming, that was my first OR course at Cornell, I thought, hey, okay, here seems to be a really interesting way of looking at real life problems and turning it into a math model and solving it. So to me, again, it seemed like maths with a purpose. So that's how I got into operations research. So the question about how did I get into data science? Well, data science, the term, is something that people use only recently. Previously, we used to study statistics, optimization, forecasting, and all these very many different subjects, and all of them had a math foundation, right? So data science, what we call data science, is essentially the study of taking data that we see a lot of everywhere and turning it into value using different types of math models. So the math models could be statistics, it could be operations research, optimization, data mining, machine learning, you name it. So essentially it's taking vast amounts of data, turning it into value that can benefit the world. So nowadays, when we talk about data science, that's how I view it. It's essentially going from data to value using math models. So I ended up with the field data science, but it was not called data science in those days. My department, my division, when I finished my PhD, I went to work for a software company, and my division was called Analytics R&D. So, that's also people call data science departments analytics as well, or business analytics and so on. So those are all the things. So that's how I went from maths to data science, and that's a little bit about my journey.
Thank you so much, Dr. Kulkarni. I think that was a very insightful discussion on how data science was perceived earlier and what it's called now. I understand that you have pursued operations research and data science both academically and in the industry. I was just wondering how different is it to work with operations research in academia versus in the industry? And is there one that you particularly like working with? Like, which one do you personally prefer?
Okay. All right. That's an interesting question. And let me give you a little bit of my journey again, about my working journey, working career, right? Because that will give you an idea of how I have an experience in both worlds. So after I finished my PhD, like almost anyone who does a doctorate, most people like or want to become a professor. They like going into teaching. They like to be a teacher, a professor at a university because of the research, working with students, etc. So I also wanted to become a professor, and I got a position as an assistant professor in Chapel Hill in North Carolina, which is where I live now. And my husband is also in the same field. He also has a PhD in operations research, and he graduated with a PhD a year before I did. He got a professor position in the same university. So I got a visiting position. It was not a permanent position. And being a small town, it was difficult to find a full-time academic position for both of us in the same field. So after 2 years as an assistant professor, I started looking around for another job, and I was constrained geographically. I did not want to move out of North Carolina. I wanted to stay close to my husband. And so I looked around and I found a job in a software company, and I took that job. Of course, in the beginning, I was disappointed that I could not continue with an academic career. But it turned out that I got the best of both worlds, because in a way, my company is responsible for producing the world's largest analytics software portfolio. And so we had a lot of very, very smart people working in all these fields. So the people that I worked with were very very similar to what you would find in academia, working on tough problems. And also, we had a history of working with local universities. So I used to work with the universities locally, work with interns, student interns. Of course, we employed students as they were interns who then became full-time. So I had this foot in both worlds. So I felt like I was able to get a taste of academia, but also be in industry. The main difference from a working perspective is that if you are in academia, most professors have a lot of independence on what problems they work on, what type of research they pursue, and what they want to do with their free time. When you're working for a company, you have specific problems that you have to address, but that also is a challenge as well as makes it interesting, because you're working on some real world problems using some of the same techniques, right? And so that's, in that sense, that's the difference between the two worlds, the types of problems that you work on and who you interact with. And I got a wonderful chance of working with a lot of academic people, as well as, of course, my whole team. Then I retired at the end of 2018. And since then, I've been doing things like this, talking to young students and university students and professors and other companies, etc., talking about my experience.
That's super cool. I mean, you're having this wonderful career, at being vice president at SAS and now president elected in Forms, and doing all these wonderful things. Can you tell us if there's any specific way, or how did the people around you support you, especially because in today's climate there's so few women in the science and tech space and data science. Can you tell us a bit about that?
Yeah, I'd be glad to. So, like I mentioned already, I was the only girl in high school in maths, and my professor was very supportive because he actually thought it was a way to make others do better, because he could point to me and say, hey, do better than that. And so he was always very supportive of me. I was lucky through the rest of my college career because I always had a few girls in my class. And so we all worked together, we studied together, especially when I was doing my PhD. That year, especially, we had an unusually large number of girls. We had 5 girls in my cohort out of a class of maybe 15 or so. And we all used to study together in a group. So that kind of support system always helps you during your college career. Then when I went on to start working at SAS Institute, it turned out that we did not have that many women in analytics, but there were a sufficient number. And so you learn to work with them. You form a group, you talk to others, and you make sure that they are all in a group. And this ability to share your experiences always matters. But more importantly, when you're working on some really complex problems like the ones we did, it doesn't really matter whether you are a man or a woman. The fact that you're all like-minded people, you have the same interests, you want to work on the same types of problems, and they're all smart people, that was the primary factor. So I did not at least feel too much that I was held back because I was a woman. But there were enough male and female colleagues who were very supportive, and we all wanted to solve the problem. And so I think that's what made the difference. So I was lucky in that I had a lot of women friends, but my male colleagues were also equally supportive. And so that always helps. So the thing I would recommend to any of you as you go through your career is to try to find that cohort of people that you can work with, that you trust, and you can develop that group so that you can count on them, you can learn from each other. And that's what makes a difference in whether you can succeed in your school, your career, or whatever it might be.
That's really wonderful. Yeah. I mean, let's switch gears a bit here, because I'm thinking about, you're talking about these new teams you worked with, and how it's, really finding unity through having that sort of support system and working towards common goals. You worked with so many teams. You also sort of focus on interdisciplinarity because you have such large teams and you're solving these problems through different ways. Can you tell us about that interdisciplinarity, how you worked on solving problems, with some examples, and how we can also build that mindset?
Yeah, sure. I'd be glad to do that because you're asking me a question that is a personal passion of mine. So when I started working in SAS, I was an individual contributor. I was a developer working on scheduling problems in the optimization software. So just to give you a background, SAS Institute develops a software portfolio of products. There's a large portfolio of products, including quality control, optimization, statistics, data mining, forecasting, and so on. So these were all different groups that were part of the entire R&D structure, and I was in the operations research group. And as we started building the optimization software and saw the different applications of it, I could see that there are ways in which some of the optimization techniques could be used to improve some of the other methods in, for instance, in data mining or in statistics. There were some inbuilt optimization problems which could use the methods that the optimization team developed. Likewise, we also built some software solutions which addressed specific business problems. Like, for instance, an example would be when you go to stores, you see all these sales, right? You see these different sales, you see that something has been marked down, there's a clearance sale. Have you ever wondered what kind of technology goes into them deciding, okay, this set of saris or this set of clothes should go on sale just before Diwali or whatever the case may be? How do they decide that? So basically, the way they decide that is by looking at what is the forecast, what can I predict as how many saris of this kind will be sold, how many vessels of this kind, steel vessels or whatever it might be, will be of interest in this particular season. So there's forecasting that comes into play. And then they try to figure out, okay, if I reduce the price here, will the sales increase enough to make up for the reduction in price? So now that becomes an optimization problem. How much can I reduce it? So you see that in one particular problem solution, you have to incorporate all these different types of techniques, right? And so seeing that putting all these different tools from different disciplines together to solve a bigger problem actually gives you a bigger benefit. So I like to, you might have heard of the phrase, the whole is bigger than the sum of its parts. So if you take lots of parts and put them together, the entire picture that you make is actually bigger than just adding them individually. So that's how it was. So I could see that it was important for all these teams to work together, not only to improve their own particular products, but also the products that can be put together, combined together to form a big business solution. So I started promoting that idea, and eventually the chief executive, the owner of the company, recognized that it makes sense to have an advanced analytics division which incorporated all of this, and let's make sure that they all can work together. And so I was given the charge of leading that division actually, and we made sure that there was a lot of interdisciplinary collaboration. So that's one of the directions that I was very fond of pursuing, and I think it made a big difference. And now that I'm retired and I'm now working as I'm a part of the Informs board. Informs is the Institute for Operations Research and Management Science. So this year I'm the president-elect on the board of Informs, and so one of the things we're also talking about, even in the broader sense, is how do we make sure that all the disciplines can work together. So that's a little bit about interdisciplinary collaboration and the value of it.
Yeah, thank you, Dr. Kulkarni. I just think it's amazing that how supportive your family, your colleagues, and your high school math teacher have been in this entire journey. So I was just looking at one of your interviews by Products by Women, and you emphasize on the importance of being confident in your abilities and being assertive. However, according to several recent surveys in current times, I think imposter syndrome is something that's extremely common, especially in women and non-binary persons in tech, academic, and professional workspaces. So I was wondering if you have any thoughts on how we can make it better for people in at a personal level, like what can people do at a personal level and what can be done at the institutional level. It would also be great if you could share if any of your experiences, if any, with imposter syndrome, and if so, what helped you snap out of it.
Okay, yeah, I'll be glad to do that. So let me start by asking, have you felt nervous before giving a talk or doing anything? Have I felt nervous about taking on a new role? Have I wondered if I have the right skills? Have I been nervous before giving a presentation? I would say yes to all of that. But I had never put the label of an imposter syndrome to this feeling of anxiety until recently. I think I've been seeing that term being used more, and people have asked me that. And it was interesting, would I call what I feel an imposter syndrome? In some sense, that label has a negative connotation. And it seems like, let's just talk about it as, natural anxiety that you feel before you start anything. And yeah, it is true that girls and women tend to be a bit more anxious about that. But that's anybody can feel that. There are very few people who are never anxious about getting up on stage. I know some of the best public speakers have said that they spend hours just rehearsing before they get on stage because they want to make sure that they do the right thing. So interestingly, just this morning I was looking through what does Google say about the imposter syndrome, and I found this really, really good article from a Harvard Business Review, which says that it's not really a good idea to tell women they have imposter syndrome, because just saying syndrome makes it sound like they have a failing and a weakness. So that's one aspect of it. But nervousness and anxiety about fulfilling a role, yeah, you do feel that. But then what has helped me get over it and get through it is telling myself, for instance, that I have been selected to do this job. I have been selected because what I bring to the table. And I have been selected because somebody believes that I can do it. So take that belief and do that, right? Having that gives you confidence. So the anxiety also adds some adrenaline to your system. So you tend to perform better too. People always say that if you have adrenaline, you can run faster in a race, you can do better than before. So think of it as a positive and put that to use. So that anxiety pushes you to do better because you will prepare well, you will have all the points ready, and then you can speak to any audience. So if you're ever starting a project anew, it's obvious, it is very common to feel nervous about it. If you're starting a new job, if you're going to a new place, but talk to the experts, find out as much as you can about what you're about to do, what you're required to do, study the topics that you may not be familiar with, prepare for it, talk to your peers and get their input, and then go forward. So it's very, very important for you to recognize that you're anxious and do something about it, right? It's also very important to have some role models. So watch some presentations, watch how people address themselves. And it's also very valuable to take some speaking lessons or presentation skills. So nowadays, in almost any role, these are called soft skills, whether you're able to communicate, whether you're able to talk to an audience. So take some classes to do that, because that will prepare you to do better. So again, it goes back to what I said, preparation. So have good role models that you can follow. Institutionally, what can institutions do, organizations do? I'm glad to say that almost every organization nowadays is paying attention to the fact that you need to push this diversity factor quite a bit. You need to encourage the minorities. You need to encourage women to come forward. So make sure they have sufficient role models and encourage them to have a mentor, encourage them to work with others. So these are some things that we can improve at an organizational level or even at the societal level. So pull others forward. And so if you have been able to succeed in something, look around you, see if there is anybody in your peer group or among your juniors or among the high school students that you can bring them forward, help them and be a role model for them. So these are some of the things that you can do personally, and you can also encourage your organization to do. And the women in data science, this entire group, I'm very proud of them because they spend a lot of energy in making sure that they have women speakers, women leaders who talk to the youngsters and teach them how they can succeed. So I think we're doing the right things and we'll get there.
Yeah, thank you so much. I think that's wonderful. I can really see um, this sort of constant vein of optimism and interdisciplinarity and diversity throughout your life. So I think that's just a really inspiring thing to have, for us and for anyone else who's watching this. Um, Sort of an interesting thing that I also see around is, with machine learning and such high levels of automation today. Do you think the role of humans might go away or change?
I don't think so. I think all of us can heave a sigh of relief when we say that no, humans will always be needed. Let me take a little bit of time to say, what is it when we talk about machine learning, artificial intelligence? What are we using machines for? We are using machines to do things that humans do, but do them much faster, so much faster, be able to look at lots and lots more data very, very quickly because of the computing power that exists out there, right? So that is what machines are doing for us. But at the same time, we cannot take humans out of the loop, because at any point in time, we need to make sure that the decisions that are being taken satisfy the right ethical qualities. They satisfy the right, that there are proper safeguards put in place. One of my colleagues likes to say, whenever we get on a plane, we all know that almost 90-95% of what happens on the plane with regard to the flight is done by autopilot. There is an autopilot on board the plane, and that's taking care of everything. But if you did not see a pilot and his co-pilot sitting in the cockpit, would you really get on the plane? Probably not. I think we are a long way from that, right? So that's because you still need somebody to deal with the real emergencies. But the routine things that take place automatically, that we have a lot of data about, should be possible to delegate to machines. But you will always need a human around, and humans are the ones who are eventually actually even building the software, right? So the skill set changes. So even when we're talking about medicine, for instance, there are lots of things that now are done automatically, like in diagnostic screening of cancer patients, skin cancer. It's told that, a machine learning algorithm can do as well as very, very advanced senior level dermatologist in detecting if a lesion is cancerous or not. So dermatologists, even senior ones, can use these tools to augment, to help them, so that they can discard the ones which are clearly not a problem, and the ones which are clearly cancerous, they can decide based on that. But anywhere in between, they'll need to put a little bit more thought into it. So you can see such examples everywhere, where you can use the machines to weed out the edge cases, but then do some more finer tuning in terms of some of the special cases. So that's where machines come into play. But the role of humans as oversight, human oversight, is always going to be there.
Thank you, Dr. Kulkarni. I think that's very interesting. So I want to know, as students like Ruthu and I enter academic and industry workspaces, is there any advice that you would like to give to students like us? Anything in particular for girls, or students in general?
Uh, Good point, right? Good question. The thing is, nowadays, almost every field is really, really seeing the value and needs computer programming, computer software, and heavy duty of some of these methods that we've been talking about: optimization, forecasting, statistical analysis, etc. We've seen so much now, especially this past year, we've seen a lot of analysis that gets talked about even in the public media, in newspapers. When would we have imagined that people would be talking about the efficacy of tests, whether the COVID test has a false positive or false negative. Those are all very statistical terms, but they've become commonplace because it's pervasive. The use of all these methods is becoming so pervasive. So if you ask me, what kind of career I can hope to pursue, I would say that the world is wide open. The field is wide open. Previously, when you were a student who was interested in math and computer programming, you probably had very few disciplines, probably manufacturing or logistical operations in some supply chain company, etc. Those were the options that were open to you. Nowadays, it's ubiquitous in almost every field. They require you to have this knowledge. So you can choose if you're interested in doing social good, or if you're interested in doing some healthcare related work, or if you're interested in doing some environmental type of work. And I'm mentioning these specific areas because I know from my experience seeing some of the daughters of my friends and colleagues, especially the girls, are very much interested in these types of fields. So it doesn't mean that in order to go to those fields, you need to give up your love for math. If you love maths, if you love computer programming, you can get into all these fields and still make a difference. So the careers that are out there are very, very large and vast. You just have to explore. Just look around you and see, and maybe take one or two classes where, if you're interested in healthcare, take a class in healthcare applications of data science, or environmental applications of data science, and see where these things get applied. So that will give you an idea of the types of problems to solve, because at the end of the day, all of us want to solve problems, right? And knowing that there are problems to solve in every different domain is what makes this such a rich field. So I envy the people who are just starting now, because the world out there is rich in problems. And it requires people like you who have studied data science, computer science, any one of these fields, to go forth and conquer the world, right? So there's a lot of things you can do. So don't be limited by what you see around you. And now, you just go to the internet and search for what types of problems are being solved, and that will give you some ideas, and maybe you'll find something new. So there's a whole bunch of things that's out there for you. So you're in a good place.
Thank you so much. This whole session has just been super brilliant and interesting and inspiring. But unfortunately, we're nearing the end. So, is there any one takeaway that you'd like to give to students or professionals or anyone watching today? Any piece of advice, anything?
Okay. Well, I'm always a super achiever, Ruthu. So it's not just one piece of advice. So I'll give a few points of advice. Okay. So just remember, as you finish your studies, that your entire life, you should think about it as a series of lifelong learning in opportunities. So wherever you go, you will have to learn new things. When you get a degree, whether it be a bachelor's or master's, what you're learning most importantly is the ability to learn. So remember that. So you can actually pick up new skills, and you will be required. Just imagine when I was studying, when I first started at Cornell, even, one of the world's largest, biggest universities, best universities, the computers were really old fashioned if you compare to them now, right? How much it has progressed, and the amount of learning I had to do to learn all of that. When we started doing distributed computing, everywhere you keep learning about new areas, etc. So lifelong learning is something that you have to get used to, because you have to learn how to do things better and learn new skills. The second thing I would advise for people who are entering their workforce is learning to work in a large team. And when you have different people working with you, it is very important that you see the big picture. And you have to understand first what is the big problem you're trying to solve, and what is everybody's input, what does everybody think about it, right? Since most of the audience here is Indian, I'm sure you all know the story about the six blind men and the elephant. They were placed in front of the elephant and they were asked to touch the elephant and say, what are you looking, what is in front of you? And each one comes up with a different part. They'll touch a different part and they think that it's a wall, it's a snake, it's a trunk, etc. So why? Because they're saying they're able to touch only that part, right? So I love to tell the story of this blind man and the elephant. Unless you have somebody who can step back and look at the entire picture, you won't even know that you're looking at an elephant. So what is it that you're trying to solve? So listen to them, understand everybody's perspective. You may learn something new that will help you. So then taking a seat at the table is something that my boss told me very early on. I was invited to come to a meeting on behalf of somebody else. My immediate boss couldn't come, but then the VP said, why don't you come and represent him? So I sat at the outer periphery of the room. I didn't sit at the conference table. So the VP said, hey, Radhika, you have been asked to come to the meeting. Come and take a seat at the table. So it was literally him telling me, take a seat at the table. But that's a metaphor that you will see being used in anybody who's talking to leadership qualities. Learn to take a seat at the table. Again, remember, you have been invited to participate because of your knowledge and expertise. Don't shy away. Be confident in your abilities and be ready to speak up if you need to express yourself. Then especially something that I would leave as a parting advice to a woman leader is be yourself. Don't try to imitate men just because you see the role models around you are the men, because you have some strengths as a woman that you can use. And something that I think is one of the natural strengths that we all have as women is a deep sense of empathy towards others. So that empathy will help you understand your team. So as you build a team of people that looks up to you for advice and guidance, treating them as a family and treating them as some people that you're invested in their success, that will help them succeed. So that's a natural strength that we all possess as women, that feeling that we want to do the best for our family, the feeling that we need to be empathetic towards the others. So that's how you need to feel and use that strength, right? So I always like to say, be assertive, but don't be aggressive, right? Make sure that you use your voice to be a strong voice in a gentle way and lead them, right? Encourage your team, support them, and push them to do better, and you will succeed.
Wow, it's just been so wonderful to talk to you today. And you were talking about finding and having role models to look up to, and you are one of our role models. So,
Thank you. Thank you so much. Thank you. Both of you, I must say, I admire both of you. I don't think at your age I would have had the courage to do what you are doing right now. So keep it up. Keep it up. And I wish you all the best. And all the students who are in the field of data science, computer science, you've all chosen something that is got a bright future for you. So go forward, conquer the world, be successful. Wish you all the best.
thank you.
Thank you so much. Thank you for giving
Thank
me
you
this
so much.
opportunity. Thank you.